So welcome really to this latest video on 162 Maths, and in this video we'll be going over a GCSE Maths practice paper from the higher tier, set 4 paper 2, which is a calculator paper. Now before we get started, a little reminder that you can find a question breakdown, a link to the copy of the paper and a link to the contents page of 162 Maths, so you can easily access all the videos on the channel along with all the topic tests, the audits and the other exam paper walkthroughs. So moving straight on to question 1, it says work out 5 to the power of 12 divided by 5 cubed multiplied by 5 squared as a power of 5. So for this, what we need to do is remember the laws of indices, where we're dividing, we subtract the powers, and when we're multiplying, we add the powers. So this is going to be 12 minus 3 plus 2. 12 minus 3 is 9, and 9 plus 2 is 11. So then we need to circle 5 to the power of 11. Now here, just be mindful that using the rules of BIDMAS, that you might think to yourself, when we write the sort of instruction like I've done here, you might think we add the power, do the addition before we do the subtraction. So here we'd end up with 12 minus 5, but that would be actually incorrect. What we need to do is do it from left to right when we have subtraction adding, and that will give us the answer of 11. That's probably why 5 to the power of 7 is not an option. Moving on to question 2, it says work out, and we've got two vectors that we need to then subtract. So for this, all I need to do is subtract the top two numbers and then subtract the bottom two numbers. So here I've got minus 4 minus 5. That turns to a plus, so that becomes positive 1. And I've got minus 7 minus 3, which is minus 10. So the one I want to circle is the fourth option. Moving on to question 3, it says circle the nth term of the linear sequence. So to find the nth term, what I need to do is find the difference, which here is plus 4. And so I'm going to end up with 4n. And then what do I need to do to get from 4 to the first term? I need to take away 1. So the nth term is going to be 4n minus 1. Moving on to question 4, it says f of x equals 8x minus 5. Circle the value of f of minus 2. So what we need to do is just substitute minus 2 wherever we see an x in the function. So that's going to be 8 multiplied by minus 2 subtracted by 5. So that gives me minus 16 minus 5, which is minus 21, which is our second option. Moving on to question 5, it says the nth term of a sequence is given by 3n squared. What is the position of the term in the sequence? That is the first one with their value greater than 1000. So for this, what we need to do is first of all do 3n squared is greater than 1000, and what we need to do is find the position, which is what the question is asking me. So I need to solve this inequality. So here I've got n squared is greater than 1000 divided by 3, and then I've got n and then the square root of 1000 over 3, which if I type into my calculator, I get an answer of 18.257. Now here what I then need to do is to either the answer is going to be 18 or 19. So now if I substitute 18 in there, I'm going to get 3 lots of 18 squared, which if I type that into my calculator, I get an answer of 972. But if I do 3 lots of 19 squared, I get 1083. So the question then is, the answer, sorry, is going to be 19. Moving on to question 6, it says £4,000 is invested at 1.5% compound interest. Show that the value of the investment after 2 years is 4,120.90. Well, the formula for compound interest is the original amount, or the starting amount, multiplied by the percentage, the decimal multiplier after the increase. So it's 100% plus 1.5%, which is 101.5. Convert that into a decimal, so that's going to be 1.015 to the power of the number of years, which is 2. So if I type that into my calculator, I do get an answer of 41290. But this is what we want to write. Then for question 6b, it says in the third year the interest rate falls to 1.4%. In the fourth year the interest rate falls to 1.35%. Will the interest for year 4 be more or less than the interest in year 3? Tick a box for your working. Well, for this, if we start with, so in the third year, now when it comes to these questions, I would always do your working out before you tick the box, because what you want to do is show the evidence and then make your decision. So in the third year I've got 4120.8, I think it was, let me just double check, 0.9. And if I multiply that by the interest rate fall, so that's going to be 1.4, so that's going to be 1.014, and that comes up to a value of, well, actually what we want to do here is actually work out the interest amount. So here, if I just multiply that by, well, actually we'll do that, so 4120.9 times 1.014 gives me 4178.5926, which for this is an interest amount, because that's what we want to work out, of, and then 4178.592 minus 4120.9 is an interest amount of £57.69. So then for the fourth year, the new amount is 417.8.5926. I'm using the exact values, not rounding, multiplied by 1.0135. And I get an answer of 4142. And actually we do that in a different colour. So I get 4235.0036, and that is an interest amount in which I'm taking away this number from what it was at the start of year 4. So minus 4178.5926, and that gives me an interest amount of £56.41. So here we can see that will the interest in year 4 be more or less than the interest in year 3? It's going to be less. Then moving on to question 7, it says work out the length of x. So this it's going to be a trigonometry question, because I've got a right angle triangle, two sides and an angle. So if I start by labelling what I know, so I've got theta, I've got the hypotenuse, and I've got the opposite. So I'm going to be using sine, so sine theta equals opposite over hypotenuse. So this is going to then equal sine 20 equals x over 12. So x equals 12 multiplied by sine 20, and that's going to give me an answer. I'm just typing that straight into my calculator. Gives me a value of 4.1, and that's to 1 decimal place. Now again, if you have rounded your answer up, always state what you've rounded your answer to. Worst case scenario, if your rounding's a bit dodgy, just copy the answer on your calculator. Moving on to question 8, it says write down 140 as a product to its prime in index form. So here, if I do my factor tree, I've got 14 times 10. Neither of those are prime, so I've got 7 times 2. Both of those are prime, and 5 and 2. So then multiplying this out, I've got 2 times 2 times 5 times 7. So that's 2 squared multiplied by 5 multiplied by 7. Alternatively, what you could have done is done this on your calculator. So if I just typed in 140, press equals, then press shift and fact, and as you can see, it comes up with the answer. Moving on to question 9, it says work out the values of a and b in this identity. So what we need to do here is compare the coefficients. So the first thing I need to do is expand this left hand side. So here I've got 3ax plus 6 minus 4x minus 4b, and that is equivalent to 11x plus 14. Now if I collect all the things with x's first, so that's 3ax minus 4x plus 6 minus 4b, and then factorise this, in which I factorise with respect to x, so I've got 3a minus 4x plus 6 minus 4b, and just pull that in brackets, and that's 11x plus 14. So what that therefore means, comparing the coefficients, is 3a minus 4 must equal 11, and 6 minus 4b must equal positive 14. So here 3a minus 4 equals 11. Then solving this, I get a value of 5. And then solving 6 minus 4b equals 14. Well, 6 equals 14 plus 4b minus, and that's going to be 8 equals 4b, so b equals minus 2. And there are my values for A and B. Moving on to question 10, it says the diagram shows a semicircle with diameter of 14 centimeters inside a rectangle. Work out the shaded area. So if I just zoom out, just so I've got a bit of room to do the working out. So for this, the shaded area is equal to the area of the rectangle minus the area of the semicircle. So this is the general rule that I'm going to be using to work out what the answer is. Now, as the base of the semicircle is 14, that this length here, which is also the height of the rectangle, is going to be 7. So here I can then work out the area of the rectangle, which is going to be 14 times 7, which, if I just type that into my calculator, gives me 98. So then to work out the area of the semicircle, which is half the area of a circle, well, that's going to be pi r squared divided by 2. R is 7, so that's going to be 7 squared multiplied by pi divided by 2, which is 49 pi over 2. So then I can then work out what the shaded area is going to be, which is going to be 98 minus 49 pi over 2. Now again, leaving your answer in terms of pi, you could leave your answer like that, but typing that into your calculator, which is something that I'd recommend that you do, you should end up with an answer of 21.03097999, which I'm just going to round up to 21.0 to 1 decimal place. Moving on to question 11, it says the table summarises the amount spent of £8 by customers in a shop in 1 hour. And for 11a, it says work out the estimate for the mean amount spent per customer in 1 hour. So for this, because we've got a group table, what I need to do is create a midpoint column. So here, to work out the midpoint, we just add the upper bound plus the lower bound, divide by 2. So this is going to be 5, 15, 25. And then for this one, because it's more and the frequency is 0, I don't actually need to worry about that one. So then I need to create my fx value. So I multiply the frequency by the midpoint. So that's going to be 18 times 5, which is 90. 15 times 15, which is 225, and 7 times 25, which is 175, giving me a total. Well, the total frequency is going to be 18 plus 15 plus 7, which is 40. And the total fx, which is 90 plus 225 plus 175, which gives me 490. So the estimated mean is going to be 490 over 40, which gives me an answer of 12.25. Now, does that answer look correct? Well, yes, it does, because majority of the data is, again, within this group here, and as you can see, my estimated mean is quite close to 10, which is the most popular one, and so yeah, I would accept that as my final answer. Moving on to 11b, it says using the till receipts, the manager works out the actual mean amount spent for each group. and it says, without further calculation, determine whether the actual mean of the 40 customers will be different to the estimate in part A. And for this one, what we need to do is we need to compare this column to the midpoint column. Now, as you can see, in part A, for the first row, we used £5. So as you can see, this amount here is lower than what was used. And also the same for this one, that also was lower. So that means that the answer, therefore, is going to be lower. So again, to give a reason for the answer, we could say that a higher value for 0A to 10 and 20A to 30 was used in the estimate. So something along those lines would be absolutely fine for the 2 marks. Moving on to question 12, it says the whole number from 1 to 15 inclusive is picked at random. And it says M represents multiples of 3 and F represents factors of 24. Using the Venn diagram, work out the probability is greater, well, which of these two probabilities is greater. So let's first of all complete the Venn diagram. So in terms of the values for M, so we're looking at the numbers of 1 to 15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. And we're cleaning those numbers, it says inclusive. So multiples of 3, we've got these circle numbers. So we've got 3, 6, 9, 12 and 15. For factors of 24, well, we've got 1, 2, 3, 4, 6, 12, and that's pretty, oh, 8, I forgot. So there we go. So here I've got 1, 2, 3, 4, 6, oh, don't know what number that was, 8, 12 and 15. So looking at the numbers that appear in both, well, I've got 3 that appears in both, 6 that appears in both, 12 that appears in both, and that's it. And now I've put 15 there, so let me just get rid of that there. So they're the numbers that I'm going to put in the middle. So I've got 3, 6 and 12. The ones that are exclusive to F are 1, 2, 4, 8, and the ones exclusive to M, which are 9 and 15, and the ones that go outside are going to be 5, 7, 9, 10, and I've got 11, 13 and 14. So once I've completed my Venn diagram, I can now focus on these 2 things here. So here we're looking for a number of multiple 3, given that it's also a factor of 24. So here I'm just looking at the multiples of 3, so I'm just looking at these ones here. So multiples of 3, given that it's a factor of 24, actually it's the wrong one I've circled, so it's actually going to be out of this pool here. So from that pool there are 1, 2, 3, 7 numbers, and out of those, how many are multiples of 3? That's going to be 3, so it's 3 out of 7. Then for the next one, it says the number is a factor of 24 given it's a multiple of 3. So this is going to be using the M circle, in which you can see I've got 5 numbers in total, and how many of those are in the middle? 3. So from this, all we then need to do is compare the 2 fractions, so we can see here which of those 2 probabilities is greater. So as 3/5 is greater than 3/7, the probability, the number is a multiple of 3 given it's a factor of 24 has a higher probability. And there we go. Moving on to question 13, it says y is inversely proportional to x for positive values. When x is equal to 3.5, y is equal to 4.2. Work out the value of y when x is 5.6. So this is an inverse proportional question. So first of all, we set up the formula. So y is proportional to the inverse of x. I then replace the proportional symbol with equals k. And then I substitute these numbers in to work out what k is. So I've got 4.2 is equal to k over 3.5. So k equals 3.5 multiplied by 4.2. So k equals 14.7. So then the formula is going to be y is equal to 14.7 over x. So all that's left for me to then do is substitute x equals 5.6. So y equals 14.7 divided by 5.6, which gives me an answer of 2.625. Moving on to question 13b, it says on the grid sketch a sketch to show the relationship between y and x. So for this, all I need to do is plot this formula here. Now again, x is only positive, so we're only focusing on values where it's greater than 0. So if I do a table of values, just to get a general ballpark of what it's going to be, so at 0, it's not going to be touching, so that's going to be infinite. At 1, it's going to be 14.7. When x is 2, it's going to be half of 14.7, which is 7.35. At 3, it's going to be 14.7 divided by 3, which is 4.9. So generally speaking, what the graph is going to look like, it's going to look something like this. Now I strongly recommend you do not add numbers to the axes. If you do, it just makes it a little bit more difficult, but I would say that your graph should look something that looks like a curve shape starting high and ending low. Moving on to 14a, it says the product of a times 10 to the power b and 3.8 times 10 to the power 6 is 2.318 times 10 to the power 3. Work out the values of a and b. Well, let's have a look at this then. So it says the product, so what we need to do then is multiply these two things here together. And that equals 2.318 times 10 to the power of 3. So comparing and multiplying this out, we get 3.8a multiplied by 10 to the power of b plus 6 equals 2.318 times 10 to the power of 3. Now from this, what we know is that 3.8a must equal 2.31, 2.318, I should say. So 3.8a equals 2.318, so a equals 2.318 divided by 3.8, and if I type that into my calculator, I get an answer of 318 divided by 3.8, and that gives me a value of 0.61. And then b plus 6 equals 3, so b equals minus 3. Now if I substitute those numbers into this, then what do I end up with? Well, I end up with 0.61 times 10, sorry, I'm going to substitute it into this here. I get 0.61 times 10 to the power of minus 3. Now this is not in correct standard form, so what I need to do is I'm going to need to make this number bigger. And so if I make that a value bigger, I need to make the b value smaller. So that's going to be minus 4. So here my a value is 6.1 and the b value is going to be minus 4. It then says for 14b, write down a number in standard form that is more than 20 million and less than 30 million. So 20 million is 20 times 10 to the power of 6, which is 2 times 10 to the power of 7. And 30 million is going to be 3 times 10 to the power of 7. So what I'm needing to do is just write a number between those two. So what we're looking for is a number that's between 2 and 3. So we just pick any number between 2 and 3. So I'll go for 2.6. and then just write to the power of 7. And so here we just want to make sure that the a value is between those two numbers there, but again it can't be 2 and it can't be 3, and again you can have as many decimal numbers as you want. Moving on to question 15, it says e equals 25 plus 2p minus pq when e equals 1 and q equals p. Work out the values of p. So for this, let's substitute the numbers in. So we've got 1 equals 25. Now looking at this, what I can do is I can just write q equals p. So wherever I see a q, I'm just going to write p. So here I've got 2p minus, and pq is going to be p squared because they're both the same thing. Now this is now slowly starting to look like a quadratic. So here what I've got is, if I take all of this over to this side, so I keep p squared positive, I end up with p squared minus 2p minus 24 equals 0. Now from this, what I need to then do is factorize the quadratic, or I could use the quadratic formula to solve. But here I'm going to end up with minus 6p plus 4 equals 0. So p is going to equal positive 6 or minus 4. So here I'm just going to write 6 or minus 4. Moving on to question 16, it says Sophie is completing a long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So for this, what we need to do is first of all work out what her best jump is. And so we're doing 5.25. Now it's going to be a percentage increase of 8%. So that's going to be multiplied by 1.08. So we've got 5.25 multiplied by 1.08, which gives me a distance of 5.76 meters. Now in terms of the winning jump, well, that was 10% lower than her winning jump. So what we then need to do is do 5.67 divided by 0.9, because it's a 10% decrease, and typing that all into my calculator, I get an answer of 6.3 meters. Then moving on to question 17, it says, what is the equation of a circle with centre 0, 0 and a diameter of 6 units? Circle your answer. Well, for the formula for the equation of a circle, it's always this, where the radius, now here we know that r equals 3 if the diameter is 6. So then what the equation is going to look like is x squared plus y squared equals 3 squared, which is 9. So the one I want to circle is the third option. Moving on to 17b, it says which of these points lie on the circumference of the circle. So what we're looking at here is we need to substitute x equals the x ordinate and y equals the y ordinate, and what I want to do is I'm looking for which answer gives me 25. So here I end up with minus 3 squared plus 4 squared is going to give me 9 plus 16, which is 25. With this one, I've got 6.25 squared plus 6.25 squared, which is not equal to 25. 9 squared plus 16 squared, again, is not equal to 25. And 1 squared plus 12 squared, again, is not 25. So the correct answer is minus 3, 4. Then moving on to question 17c, it says circle true or false for each of the statements. So for the first one, it says the centre of the circle x squared plus y squared equals 25 is 0, 0, and that is true because there's nothing being added or subtracted to the x and y before it's being squared. For the next one, it says the equation of the tangent to the circle x squared plus y squared equals 25 at the point 5, 0 is y equals 5. Well, for this question, if we just do a little sketch of what the circle looks like, and that's going to be 5, that's minus 5, that's minus 5, and that is positive 5. And the point in question is 5, 0, which is this point here, and the tangent is going to be looking like that, and that is x equals 5, not y equals 5, so that is going to be false. It then says that the equation of a circle and the equation of a straight line can have either 0, 1 or 2 solutions if solved simultaneously. Now for this, it's just a case of the solutions are basically where the line and the circle intercept. So how many different times can a line and a circle intercept? Well, it can either not intercept, intercept once, or intercept twice. So that is going to be true. Moving on to question 18, it says here are two similar solids, A and B, and it says the volume of B is 400 cubic centimeters. Is the volume of A approximately 1/4 the volume of B? So if I just zoom that out first. Now we know that they're two similar solids, so what we need to do is we need to work out the volume of A. So to work out the volume of A, first thing I need to do is recognise that the length scale factor is 8/5. So that means that the area scale factor is going to be 8/5 squared, and the volume scale factor, which is what I need, is going to be 8/5 cubed. So therefore, to work out the volume of A, it's going to be the volume of B, which is 400, multiplied, well, it should be divided by, because we're going smaller, 8/5 cubed. So the volume of A, if I type that into my calculator, 400 divided by, and then we've got 8/5 cubed, and that gives me an answer of 97.65625. So then the fraction of A over B is going to be 97.65265 over 400, and what we'll do is want to compare this to being over a quarter, and we're looking forward to see whether it's approximately a quarter. So if I divide that by 400, it gives me an answer of 0.244, which I would say is approximately 0.25. So the answer then is yes. Now moving on to question 19, it says curved surface area of a cone is pi or L, where L is the radius and L is the slant height. The diagram shows a hollow cone made from thick glass. The radius of the outer cone is 10 centimeters. The slant height of the outer cone is 25 centimeters, and the radius for the inner one is 5, and for the slant height for the inner is 12.5. Work out the total surface area of the glass. Now the surface area for the particular shape is going to be equal to the donut, which is the base, plus the outer cone, plus the inner cone. Now for the donut, that's going to be the big circle minus the small circle. So here the big circle has got a radius of 10 and the small has got a radius of 5. And then going back to the diagram, we've got a slant height of 25 and this one here is 12.5. So for the big circle, that's going to be pi r squared, so with a radius of 10, so r equals 10, this one r equals 5. So if I just move down a little bit, we can then work out what the area is going to be for the big circles. That's going to be 100 times pi, which is 100 pi. For the small one, that's going to be 5 squared times pi, which is 25 pi. Subtract the 2, and that comes up to a total of 75 pi. Then for the outer, that's got a radius of 10 and an L of 25. So using the formula of pi or L, that's going to be 10 times 25 times pi, so that's going to be 250 pi. And then for the inner cone, that's got an R of 5, an L of 12.5, so that's going to be 5 multiplied by 12.5 multiplied by pi, which comes up to 62.5 pi. So then the total surface area is going to be where I add up all of those numbers up, and then writing your answer in terms of pi is either going to be 387.5 pi or I can write it as a decimal, which is 1217.367,153. So I'm just going to write 1217.4, and that's to one decimal place. Moving on to question 20, it says prove that, and then we've got this expression, is never positive. So for this, what we need to do is first of all expand some brackets. So if I take this bit here to begin with, so I've got 3. Now if I multiply out those brackets, I'm going to get x squared plus 8x plus 7. Multiplying them everything by 3, I get 3x squared plus 24x plus 21. Then expanding this bit here, in which I end up with 2x plus 5, 2x plus 5, remembering that it is a double bracket, and expanding that gives me 4x squared plus 20x plus 25. So I then need to subtract the pink from the purple, and again just making sure I'm writing that in brackets. So then what I end up with is 3x squared plus 24x plus 21 minus 4x squared minus 20x minus 25. Then from this, what do I end up with? Well, looking at collecting the like terms, I'm going to end up with minus x squared. I'm going to end up with plus 4x and minus 4. I end up with this. So then from this, as you can see, I can then take a minus out, in which I end up with x squared minus 4x plus, or minus 4, actually plus 4. And does this factorize? Yes, it does. I can write x minus 2 squared. So as you can see, this bit here is always going to be positive, or it's always going to be between 0. Well, it's going to be greater than 0 or less or equal to 0. And let's just double check. Oh yeah, that's fine, yeah. So here is going to be always greater or equal to 0. So as you can see, we've got a minus. So therefore, as minus 1 is a multiple, the answer will always be negative, because we've got a negative outside, and this bit here is always going to be greater than 0 for all values of x. Moving on to question 21, it says Lucy makes a 5-digit number using all of these cards. How many different numbers greater than 50,000 can she make? Well, for it to be greater than 50,000, 6, 7, 9 needs to be the number in front. So if I just start off with writing 6, then what I then want to do is then what other numbers can I use? Well, it's going to be, so let me just write starting with 6. So this is a product rule for counting. So starting with 6, well, I can only have one number to start with. Then for the number of combinations for the second number, well, I've got a choice of 4 numbers. Then I've got for the third choice of 3, then a choice of 2, and then a choice of 1. Then starting with 7, again, I can only choose one number to start with, then 4 times 3 times 2 times 1, and then starting with 9, got 1 times 4 times 3 times 2 times 1, and if I work those out, so 4 times 3 times 2 is 24. So the total number of combinations, if I just add those 3 24s together, I get an answer of 72. Moving on to question 22, it says the volume of a sphere is 4/3 pi r cubed. A cylinder has a radius of x and a side height of h. The hemisphere has a radius of 3x over 2. X to h is in the ratio of 4:9. Prove that the cylinder and the hemisphere have the same volume. So for this particular question, which is our last one, and just zoom out so we've got a bit of space.